Last time you looked at directional control valves. Today let's look at some of the other kinds of valves that you might find in your hydraulic system. And I think we're going to look at three different kinds. One is a check valve, which you might find in plumbing as well as hydraulic systems. Basic idea is it lets fluid flow one way and not flow the other way. And here is the symbol for a check valve. You can see it's a picture of the way it works. So picture a spring or something on the left end here. If oil came and pushed on this ball, it would open and oil would flow through. If oil tried to flow from left to right, the ball would press into this seat and oil could not get through. So it's kind of a symbolic way of representing its function. There are various different ways that these things might be configured, and some of them have a straight through flow, some of them are at right angles, some of them are integrated into other valves. A very common kind of valve is the pressure relief valve. And we need these because, and at first let me say, this is a hydraulic schematic of a system. So here's the pump. Here's the directional control valves that you looked at last time. Here are two cylinders. Anyhow, a hydraulic system is a closed loop. So the oil always goes out pumped from the tank, out to the actuators, back to the tank again. And that pump is delivering a constant volume of fluid. Well, that means you need some way to regulate the pressure so that when something gets as full as it can get, then excess oil will flow back to the tank. In this schematic, this thing here and this thing here are pressure relief valves. And they might be used if a system is overloaded, so excess fluid will drain back to the tank. And it might be used when the cylinder is fully extended or fully retracted, and the pump is still pumping oil and there's no place for the oil to go, so it goes through these pressure relief valves and back to tank. And this U-shaped symbol, again, is the symbol for a tank. So you can have simple, more direct-acting pressure relief valves. It's common to find a pilot-operated pressure relief valve. So the pressure opens the pilot, and then the pilot opens the main valve. Pilot-operated pressure relief valve. Here's the symbol for a pressure relief valve, and you'll see several things explained rather clearly in this symbol. First, over here on the left, that zigzaggy thing is a spring, and there's that variable arrow, that arrow that's sitting at an angle, that thing that always means it's variable something or other. Then this dashed line means this is a pilot-operated pressure relief valve, so that's the pilot line where a little bit of oil will come through. This thing at the bottom is the tank, so the pressure relief valve always drains back to tank. Here's a dot that means that's a connection. And you might recall that valves are always shown in their resting position in the symbol. So in this symbol, in this resting position, oil is not going to get through this valve and drain back to tank. But when the pilot pressure is enough, it will push against this body in here, push against the spring, and this pathway, the way, will get pushed over here and connect up with the main line, and oil will drain back to tank. Cool, huh? Here's a schematic with these two pressure relief valves shown as symbols. And they're sitting at different angles, but that doesn't matter. So they're the same symbol basically. Oh yeah, and one's mirror image of the other, but we don't care. So both of them are shown draining back to tank. This one drains to tank, this one drains to tank. The third kind of valve you'll encounter is a flow control valve, kind of a metering sort of thing. Here's the symbol, two curved lines, semicircular lines. You can think of them as showing the passageway necking down. And then there's our friend, the diagonal arrow again, indicating that this is a variable, an adjustable thing. Here is a flow control valve in a schematic. So here comes oil from the pump, going through our directional control valve, going through our flow control valve, and we can adjust this to allow more or less fluid to flow through at a different rate, which will control the speed of that cylinder. And you could have a flow control valve where the flow is regulated on the incoming or the outgoing. You could have a pressure compensated flow control valve. And see that little vertical arrow in the symbol? That's pressure compensated. And finally, here's a symbol for a flow control valve that has an integral check valve. So you can see in the diagram up here, there's a picture of the check valve on a spring, and flow will come through and it will hit the check valve. When it hits it one direction, over here, the flow can flow through. When it comes from the other direction, the check valve closes and it can't flow through. So here is the symbol, flow control. It's adjustable because there's the arrow. Here's the check valve that's built into the thing. There are the two dots that mean connection. And this dashed line around the outside is a line that represents enclosure. So what this symbol means is we've got an adjustable flow control valve with a check valve that's all inside the same valve body.